Now, in the earlier session or in the last session, we have discussed a problem where a plane was resting on one of its edges on principal plane, and it was in oblique condition, and we have seen how to get its projections. Now there is another condition as well. So in this session we will see to get the projection of a plane when it is resting on one of its corner, when the given plane is resting on one of its corners. Again, the idea is same. We will be identifying which one is the surface inclination. Now these inclinations can be directly or indirectly specified in the problem. So based on the given condition, we will identify the surface inclination, then the which is the line inclination, and then we will go for it. But only condition here which is changed is it is resting on one of its corners, right? So let us see how it goes. So I have this example wherein it is said that a hexagonal plane is resting on one of its corners on the vertical plane with its surface inclined at 40 degrees to VP. The diagonal containing the corner on which it is resting is inclined at 35 degrees to HP. We have to draw its projections. Now first let us take down what is given to us. Let us understand. So here the plane given to us is a hexagon. Now here deliberately I have not specified what is the side length of this hexagon. So anyway, when it is not again mentioned, we will be considering these planes to be regular polygons. So when you are solving, you may take the side length, each side to be as maybe say 30 mm, and you can solve the problem on the sketchbook. So then the condition is that it is resting on one of its corners on VP. So condition is one corner in VP. So one of the corners is in VP. Now there are two inclinations. Inclined at 40 degrees to VP. Inclination with VP is phi, which is given as 40 degrees. Another inclination in the problem mentioned, inclined at 35 degrees to HP. So this is inclination with HP, means it is theta. This theta is given to us as 35 degrees. Now I have said, first you see what are the inclinations given, then identify which one is the pure surface inclination. Now here says that the surface is inclined at 40 degrees to VP. Inclination with VP is phi. So this phi is the surface inclination. That means we are going to deal with phi first, and 35 degree inclination is the diagonal containing that corner. So it is a diagonal. So this inclination is the line inclination or of the diagonal inclination. So we will be dealing with this in the final step. So to understand, I have this hexagon with me. So it is said that a hexagon is resting on one of its corners. A hexagon is having 6 corners. So out of these 6, one of the corners is in VP, right? So, and the diagonal containing that corner. Now if this is that corner, if I am considering, so if this is that diagonal, if I consider, then a corner which is on VP, then I will be considering this diagonal, right? So I will be then considering this diagonal. It is said that it is resting on one of its corners in VP. So let it rest in this way, and this diagonal is inclined at 35 degrees to HP, right? So this is placed in this fashion. So I will be getting this final front view and final top view. right? Now, in the last problem or earlier problem where it was mentioned that the polygon was resting on one of its edges, so we have kept that edge under consideration perpendicular to the other plane. That means wherever we have drawn this edge, we have kept it perpendicular to the XY line. Now, in case of corner condition means when the polygonal plane is resting on one of its corners or the corner reference is given, and in the second inclination, the information of second inclination is given with respect to a line. So we will always keep that line. So here again, for sure, in the first step we are going to draw the true shape of the given plane and the trace in the other view, right? And while drawing the true shape, we will ensure that the line which we have to put in the second inclination or the final condition, we will keep that line parallel to XY wherever we are drawing the true shape. Now, if you see this problem here, it is said that one of the corners is in VP. So what will be my first step? I will keep all the corners in VP, right? Why? Again, the surface inclination is phi, and phi is visible in the top view, and to draw surface inclination, I need the trace. How I can get the trace? When it is perpendicular to the HP. And how I can ensure that it is perpendicular to HP? When I make it parallel to VP. So that is how we have to analyze. So, or the other way around, if you think, first it is said that one corner is in VP, so I put all the corners in VP. So the moment I put all the corners in VP, so I will be getting the true shape in the front view and the trace on the reference line. So when the plate is on VP, when I look at it from the top, I will get this trace on the XY line or the reference line. So this will be the initial step. Now, to draw a hexagon, regular hexagon, say I have to draw a hexagon of sides 30. So I take radius 30 in my compass, right? And I draw a circle. See, the side length is 30 mm. So I draw a circle with radius equal to side, right? And then I have said that whatever line under consideration will be to which I have to put the second condition, that means it is the diagonal. So I need to keep that diagonal parallel to the XY line. So this is the reference line. Now here again it is not mentioned that how much, what is the height of the center or anything is not mentioned. The distance from HP of the given hexagon is not mentioned. So we will consider it at a comfortable height. So that means now again, so I will, wherever I consider this line in the first step, we will draw this parallel to XY line, right? So that means I want a hexagon will have 6 diagonals, but I'll be selecting only one diagonal. So whichever diagonal I have selected, I'll keep that parallel to XY. That means I'll get the hexagon in this shape. So if I want to draw this in this fashion, so I will first mark one diameter which is parallel to the XY line, right? Now we take, so I have 2 points of the required hexagon. So now I take this radius in compass, this as center, I cut this here and the same radius, I cut it here, so I get this as the second point. Then the same radius, same method here, and I cut it here. So I have these 6 points of the required hexagon. So now I join all these points. So I get my required hexagon. again you will keep in mind these are all construction lines, so you will keep them faint. Just put the pencil on the page, let it its own weight work, and you get the line. Now we name these corners as A dash, B dash, C dash, D dash, E dash, and F dash. So I get this as, so this is the reference line XY, right? So now when we look at it from the top, now in this condition all the corners are in VP, so I'll get the trace of this condition on the XY line. So we drop the projectors from A, B, C, and you will see that B and F will match, C and E will match, and D. So we get the trace on the XY line as this, and these are the, so when I am looking at it from the top, this is A, this is B, F. Now B, comma F, comma specifies that BF is not an edge. These are two different points but are on the same projector. Similarly, this will be C first, then E. So C, comma E, again Y separated by comma. C and E are two different points. Then this is D. So this is how I get the first initial condition. Then what we did, so we have placed it. Now we give the surface. So we will be now include the first condition. So first we will be giving the first condition, which is the surface inclination. So now we will pull out all the other 5 corners, keeping one corner in VP, right? So when we are doing so from the top I will be able to see this surface inclination. So when I am doing so, the trace will get inclined in this fashion. So trace is getting inclined at 45 degrees. So we move ahead. So we are putting first condition. So here at a comfortable distance, I mark the first point, which will be A1, right? Now, so when we are pulling this is the trace. The trace is getting inclined, so I will be getting trace inclined in this fashion, which is at 40 degrees. So we measure 40 degrees and draw one line. Fine. And the trace length, we are just giving this inclination, so the trace length is not going to change. So we can take this trace length in the compass, right? And we mark it. And this much. So this is, and we mark all these points together. Just reproduce that same trace, and this is phi given as 40 degrees. So this is A1, this is B1 comma F1, this is C1, E1, and this is D1. So we have given the first inclination. Now we will go for the front view for this condition. So for front view, then that means we will be looking at in this direction. So the projectors will be in this direction, perpendicular to XY. So we get all these projectors as this. Now when we have given this inclination, all the corners are remaining at the same height. The heights are not changing. So simply I can drag the heights of all these corners A, B, C, D parallel to XY line. So now we can get projector of A, locus of A. So I get this as A1 dash, projector of B, locus of B, I get B1 dash, projector of C, height of C, C1 dash, D, D1 dash, E, E1 dash, and F, F1 dash. So Now we join A with B, B with C, C with D, D with E, E, F and F, A. So we get this as the projection as first condition. With first condition we get this projected shape. So now we have to put in the second condition, that is theta to the diagonal on which it is resting. Now it is resting on the diagonal or on the corner A, and the diagonal through A is AD. So that means this is under consideration. So this diagonal AD is supposed to be inclined at 35 degrees to HP. Now here we need to be careful while drawing theta. Now here what will happen? We are at this condition, and now I have to give this inclination, right? So when I am giving this inclination, fine. So that means the shape and size of the front view is not going to change. Only the orientation is going to change by this, right? So that means I have to simply reproduce this same hexagon, right, as if tilted by AD inclined at 35 degrees, right? So that means I have to reproduce this same hexagon here with A1 D1 inclined at 35. But this A1 D1 is not the true length. See, AD is the true length of the diagonal, but A1 D1 is the projected length. We have seen, because this line has got inclined with VP. So that means in front view now, in this condition, I am able to see its projected length. And I cannot give projected length to a projected, so I cannot give a true length to a projected line, right? That means for this inclination of 35 degrees, I need to find out the projected inclination, right? And that we have studied in projection of lines. So if I know the true length, if I know the true inclination, I can very well find out the projected. So I just extend this line. So we name this. So we have to tilt it. So I'll be rotating this hexagon counterclockwise, right? We will always move away from the XY line until and unless it is specifically mentioned in which direction you have to give the inclination. So I first mark one point. I extend this projector, locus of A, and I mark one point here, and I name this point as, now second condition we are going to put in, so I name it as A2 dash, right? Now theta is 35 degrees, so here I will draw one line inclined at 35 degrees. So when I am drawing this as theta 35 degrees, when this is theta, that means this length must be true length, and we know the true length of the diagonal. So here we have the true length of the diagonal. So I take that true length in my compass, A2 as center, and I mark this point. So this is A2D, right? The moment I locate this D, that means this is the locus of D for the true length, right? And for projected condition or true condition, the locus does not change. So now I also have graphically determined the projected length of AD. So I'll take AD in my compass, A2 as center, and I'll simply cut this. So this line, this inclination is the apparent inclination alpha for this given. So this point, not this one, this is true length. So first we have marked true length, we have found out the locus, then we have taken the projected length and we have marked. So we get this point as D2 dash, right? So now we have 2 points. So now on the basis of this A2 dash, D2 dash, we will reproduce the same hexagon here. Now there are two ways. So now what I can do, I can take A1, B1 in my compass, A2 as center, I will draw one arc. I'm just telling you the process how you can do it. See, so we have located A2, D2 and we have tilted it. So I'll take A1, B1 in the compass, A1, B1 in compass, A2 as center and draw one arc, and I take D, B1, D1, B1 in compass, D2 as center and cut that arc. So I have found out B2 dash. Similarly, I can take F1. So now when we are drawing, so we know this length will come out to be this length. So this center, draw one arc. I can draw another arc here. Take this distance in compass. This as center, cut this arc and cut this arc. Same thing on the other side. From D2 I can draw this arc and FD or will be equal to EA. So this as center I will cut these two arcs. So I get all the 6 points. Another simple method, very simple method can be take the compass. So take this distance in the compass. On the AD2 line you mark the point, right? These projectors are perpendicular to A1 D1 dash. So from here I can draw lines, construction lines perpendicular to A2 D2 dash, A2 dash D2 dash, and then I take these distances in compass and I simply mark them on this. So whichever method you find easier, you can adopt. So this is A2. So this I have got B2 dash. This is C2 dash, D2 dash, E2 dash and F2 dash. So this is the same hexagon we have produced here as the final front view, right? So final front view is achieved. So we have given it so it was the first inclination, then we have given the second inclination, and now we will have a look at it from the top. So now we will drop the projectors for the top view. So we will drop the projectors for the top view. Right? C2 is remaining, so we drop all the 6 projectors. Right? Now, when we are doing so, we have not disturbed phi. So that means these loci can be dragged for the final top view. So from D, C and D, B and F and A. So now we will mark the points. So projector of A, locus of A. So I get this as A2. Projector of B, locus of B, B2. Projector of C, locus of C, I get C2. Projector of D, locus of D, I get D2. Projector of E, locus of E, get E2. Projector of F, locus of F, we get F2. So now we join A, B, C, D, E, F and A. So this is how we get the final projection of the required hexagon. So when you will be looking at it from the top, so you will be getting this image as. So if you want to see the effect, you can just tilt your head and look at the plane, you will get the effect of this inclination. So that is how we see the corner condition. So that's all for this session.